Okay, question number 1. We need to identify the rank sum R1 of the sample 1 value. Why R1? Because sample 1 is the smallest sample size. So you can use Excel, that would be the best, but in my case, I have no choice. My Excel doesn't pick up, so I'm going to write down by hand. So in Excel, you can open this in Excel, load it, copy and paste in one column, and then where the home menu is, if you go on the right end, you will find there sort out. So highlight on that column, click sort out in ascending order, and you will have it. Here I'm going to place it by hand. So first it's going to be free. Let me see. It's going to be free. That's the first one. Free, 7, 9. Those are sample 1, 1, 1. And then we go 11. I will mark down only sample 1 because we are interested in sum of rank sample 1. 11, then it's coming 14th, sample 1, and then 18th, 19th, 20, sample 1, 25, 28, 30, 31, sample 1, 32, 36, sample 1, 38, sample 1, 39, sample 1, 45, also sample 1, 49, that's sample 2, 50, sample 1, and the rest is 58, and so forth, so on. It's a sample 2. We are not interested. So let's see what we have. Free, it's a sample 1. Let's line up by rank. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I'm not going further. Okay, I would just count to make sure it is correct. So 58, and then 60, 62, 69. So 20, 21, 22, 23. Let's count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And the other one is 12. 11 and 12, it makes 23. We are good. Okay. Question number 1. We need to identify rank sum R1, which means for sample 1. We have 2 samples, right? So first of all, we need to line up the both samples in one column and then assign ranks. Since my device doesn't allow me to upload in the Excel, so I'm going to do it by hand. You can upload in Excel and then arrange in order. That would be the best. But let me try to do it by hand. So 6, this is thick. Okay, 6, and then 12, and 14, and then let me change the color. 16. This is how we will recognize which one is sample 1, which one is sample 2, and then 21, no, 19, I'm sorry, 19, and then 21, 22, 24, 27, 31, 32, 34, no, 33, 32, 33, and then 34, okay, 35, 38, 40, 38, 41, 43, 50, where 43, 47, 47, 51, no, 50 has to be, okay, 50, 51, 54, 58, and 61. So we have total how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So let me count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We are good. Okay, so let me, I'm going to write down by rank. It's gonna be 1, 2, 3, 4, 5, 6, so thick, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Okay, so let's highlight them. The ones are going to be counted. 1, 2. So because we're counting for sample 1, all black colors are going to go into, why I'm going so carefully, so not to make a mistake. That's all. There we go. Now we can add. So I'm going to use my calculator, so to go fast. 1, 2, 3, that's going to be 6, 5, 11. Okay. 11. Next I'm adding 10. Okay. Adding 13. Adding 15 and 16. Well, 31, but 15 and 16. Okay, adding 19. Adding 21, 22. And that's it. I got 127. Okay, let me write down. Oh, here it is. 127. Nice work. Okay, we are done. Next one. So what is going to be next question? It's about referring to accompanying data table, which is this one. Okay. All right, what do we have here? Data table. Let me move this further. Okay. Refer to accompanying data table. Use the amount of money gross by movies with rating PGA and PGA or PGA 13 as sample 1, and use the amount of money grossed by movies with R rating as sample 2, so R2. Use 0.05 significance level to test a claim that movie with rating of PGA or PGA 13 have higher median gross amount than involved one. Okay, this is interesting. How we gonna solve? First of all, Wilcoxon rank sum test, and this is Wilcoxon rank sum because we are testing how many free, right? Yeah, we are testing free samples, right? And we don't know if testing median, we don't know if it doesn't say if they are from normal distribution. Therefore, we are using Wilcoxon sum rank test. Required 2 independent and random samples, each with more than 10. The requirements, and we have more than 10 for sure. So now identifying null and alternative. So when it's asking test claim that movies with range ratings PG and PG 13 have a higher median amount than movies with R rating. So null hypothesis is gonna be 2 samples come from population with equal medians, and alternative medians. The median gross amount rated movies is greater than median, right? Because it says higher median. So there are so many similar ones, so we need to read carefully not to choose the wrong one. 2 samples come from population with equal medians. Yeah, this is the only one. And median gross amount rated movies greater than median gross amount. Okay, A. Let's check. Fantastic work. So next, we need to find the rank, right? So I released the answer for test statistics because I won't be able to do all this counting with R1. So it's because I can't write down all this and then arrange in order. So, and I have done already, you have it in the lecture, and I did with the previous case. Let me see. 1 second. Here it is, I already counted. So the same way you're gonna do in this case, it just you're gonna use R1 as you're gonna use R1 as a PG and PG 13, which is gonna be, let me see, looking at the table from movie number 1 through movie number 12. So the step 1, you have to arrange these gross in millions in ascending order. And then, like I did in previous case, either change the color so you would recognize which one it is, or just write down in front PG or PG13 or R. There are 3 samples, 3 types of samples. Okay, then add up the ranks for R1, which is PG, PG13. And that's what we are going to use. Let me write down here A. Okay, now once you have it, since the goal is to calculate the test statistics, because we need to compare test statistics with critical value so we can figure out what to do with claim. So what is going to be next, since our z statistics is equal, our z statistics is equal r minus mu r and divided by sigma r, right? So we are going to use this r1 as a letter I have it here, whatever number you get after adding all these ranks for PG and PG13. Now, but what we can calculate is mu r and sigma r, which is going to be, our mu r is n1 times n1 plus n2 plus 1 dividing by 2, okay, and sigma r is going to be n1 n2 times n1 plus n2 plus 1 dividing by 12, and we are taking square root. And now once we have it, we can start doing math, okay? So mu r is going to be equal. So n1 is 12, so it's 12 and 12, because our one sample, let me see, where is it? Here, it's asking R1 to use as a PG/PG13, so it's going to be 12 sample size, 12 movies, and the other sample, it's going to be, since 24 movies, 24 minus 12 is going to be 12, so both of them, and 1 is 12 and 2 is also 12. So mu r is going to be 12, and then 12 plus 12, n1 plus n2 plus 1, and we're dividing by 2, okay, and it's going to be, if you add them up, it's going to be 150. Sigma r is going to be 12 times 12, and 1 and 2, and then 12 plus 12 plus 1 divided by 12, and it's going to be 17.32, 3205. Okay? So from here, we are going to calculate this score. This is what is interesting. It's going to be our A, R, right? This is summation when you add a rank of all these first 12 movies, right? So A minus mu R, which is going to be 150, and divided by sigma R, which is going to be 17.3205. So I don't know what number we will get, but we will get in there. We will get closer to Z. So it says it should be 2.627 actually. It should be, let me write down, I forgot that I had open the answer, 2.627 you should get. Okay, so from here I can calculate A. So if I take 2.627 multiply by 17.3205 and add 150, I should get this A. Going backwards, but you can do it. I'm not going to do this math now. Okay, so the bottom line is test statistics 2.627. Now let's find out critical value. Since our test claim, hypothesis claim, it says alternative one, movies is greater than median gross, which is A, greater than gross, which that means we have right tail, right? So to find critical value, we take 0.05, right? Alpha 0.05, and let me see, 0.05, I can do, let me see, 0.05 here, and accordingly it's gonna be 0.05 here, right? Why these pens are so thick? Okay. 0.05. So we are going to table, and since approximately it's a normal distribution, you are going to go to the table and get from the negative z-score 0.05 how much it will be, and you should get 1.645 negative, right? 1.6 here, let me see, and 0.04 here, 0.05, therefore it's going to be negative 1.645. And because we have right tail, because claim it says movies is greater than median gross, then it's a right tail, therefore we are using only positive, okay? Our z critical is 1.645, here it is. So if we compare for the right tail, this is 1.645, and our test statistics 2.627, which means we are going to reject null hypothesis. The test statistics is in rejection region, therefore we reject null hypothesis, and our claim alternative, which means we fail to reject, which means we are going to support. There is sufficient evidence to support the claim that movies with ratings of PG or PG-13 have a higher median gross amount than movies with R ratings. Okay, question number 13. Well, I started here, I solved. The only difference here is critical value, because we have null and alternative, it says difference or no difference. I split it, 0.05, it's going to be 0.025. Where is alpha? Let me see. Here, 0.025 alpha, because to tail I split it, 0.025 will get 0.05 if I split 0.025, and that should give you z-score plus minus 1.96. Okay, now test statistics, you are going calculate exactly like I said here. Instead here you have two only samples, right? You're gonna arrange two samples in one line in ascending order, assign the ranks, and then add which one it does want to add. Let me see. Okay, we are going to add, I think it wants R only. So this requirement is met by given data. Okay, is the sum of R we are going to use, it's a sum of a smaller sample. So our smaller sample is associate. So you're gonna count R for associate, because here we have less, see, we have less numbers there. Okay, that's going to be R2. So you arrange in ascending order, assign ranks, right, like we did in this case. It was number 1 or 2, I don't remember. And then choose, add the ranks that matching to associate degree. Okay, and that rank, once you have R, Next, you're gonna do mu r and sigma r here. Mu r, sigma r, these formulas, because you are going to use these statistics. So you need this r and mu r, sigma r. One sample is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. The other one, it's going to be, the other one which is associate, it's going to be 10 by 1 less. So N1 is going to be 11. And 2 is going to be 10. And you calculate and you are going to get your test statistics. Easily you can calculate your sigma r and then mu r, just exactly like in previous problem. And the rank that you already calculate, and rank is going to be for small sample size, which is going to be for associate. And use the sum of this rank and minus mu divided by sigma after these plugging numbers 11 and 10. Okay, so let me see. It doesn't give me the proper answer. 1 second. Okay, so negative 3.06. Okay, this is what it's going to be, negative 3 point, but that's a weird number. That's a test statistics. Okay, that's not a critical. So your test statistics you're going to get, this is all after all this calculation, like z score is equal a minus whatever mu r here will be, whatever sigma r here will be with calculations, using calculations in sigma r and mu r. So, and you should get negative 3.06. Okay, so this way, now we need to decide we're going to reject or not reject our critical plus minus 1.96, and we have negative 3.06. So it's falling in the rejection area on the left side, which means the test statistics, what is it? Not between critical values, right? Because it's not a smart way to put. So therefore, we reject null hypothesis, right? And lastly, what is this? Interpretation. So at 5% significance level, since we are doing interpretation regarding alternative hypothesis, we are saying that there is enough evidence to support, because if we reject null, then we support alternative. And our claim is alternative. Moving to question number 4. So we are going to solve, okay, precisely same way. Let me open this. Answer. Okay, good. It gave me. So question number 4, refer to accompanying data table for the changes in LDL cholesterol level in clinical trials of a cholesterol lowering drug. Negative values represent decrease in LDL cholesterol. Use 0.01 alpha, 0.01 significance level to test the claim that those treated with 20 milligram of the medication and those treated with 80 milligram of the medication, changes in LDL cholesterol have the same median. So we are dealing with two-tail test, same median. So null hypothesis is going to be equal, alternative not equal, right? And that is going to be, indeed, here it is population have the same median or have not the same or different median, which means we are going to deal with two-tail, yes? Okay, so Next, what do we need to calculate? We need to calculate test statistics. Again, test statistics, same way, adding our table, 20 milligram and 80 milligram, line up in one column, both of them arrange in ascending order, which is very easy to do in Excel, and then assign rank. So the smallest rank is going to be, smallest size is 20 milligram, so we need to calculate the rank for 20 milligram. Okay, once you calculate the rank of 20 milligram, then z-score, z-statistics, it's going to be this r minus mu r divided by sigma r. And how to calculate, you already know. All you need is sample size n1 and 2. So you can count sample size of 1, sample size 2, and do the math, and you would get z is equal 4.2. Now, next question we need to find is the value, p-value. So to find p-value, what we are going to do, we take our z-score table, right? And going to get p-value for that. Now, p-value, it's going to be 0.00, right? Therefore, for two tails, if you multiply by 2, because z-score will give you only for left tail, right? We're supposed to multiply by 2, but because it's all 0 round, we multiply by 2, we are getting again 2. So z-score 4.42, because z-score max is going 3.49, I think. Then 4.42 is going behind, and p-value is going to be 0 practically. All right. So what does that mean here? We are comparing p-value to significance level, which is 0.01. So because it's a less than significance level, then we are going to reject our null hypothesis. If we reject null, then we fail to reject alternative, and you choose appropriate answer. Okay, and the result, since null hypothesis is rejected, it appears that dosage amount have an effect to the change in LDL cholesterol. Okay, question number 15. Let's see what we have here. Question number 15. Okay, what is that? Is non-parametric test using ranks of sample data from independent sample. There is no question, is here Wilcoxon rank sum. The Wilcoxon rank sum is a non-parametric test that uses ranks of sample data from the independent population, and so on. Okay. I didn't check. Okay, let's check. Okay, nice work. Next question. What we have with question number 6. Which one is following is not for Wilcoxon rank sum? So, the Wilcoxon rank sum test is for matched pairs. So, well, this one is not, because Wilcoxon sign rank is for matched pairs. Okay? An alternative hypothesis for Wilcoxon rank sum test could have two populations having different medians. Everything else is correct, is matching, so to Wilcoxon sum rank. Okay. Number 7 is not the true for the, okay, rank sum. Two population, it is required, it's not required. Two population have normal distribution, it's absolutely not required. to answer such questions, and on the final will be such questions, I highly recommend to go over lecture and write down in what case we use which one. Okay. Question number 8. So what do we have? Question number 8. The following tables list attribute rating of male by blah, 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 blah. Are the requirements satisfied? Excuse me. Assume that we want to use data with Kruskal-Wallace test. Okay. Which one satisfied Kruskal-Wallace? Are these requirements satisfied? Okay, no, because the whale samples has at least the 5. No, it has to be, that's not the case. Yes, because the samples come from normally distributed. No, because the samples are independent. That is correct. Has to be independent random samples, and each sample has at least 5. That is the case. For Kruskal-Wallace, we have to have independent samples, and it's a minimum 5 elements sample size. We did good job. Question number 9. What we have here is non-parametric test that uses rank of simple random sample from 3 or more independent populations. Oh, that's a Kruskal. 3 or more random samples or 3 or more independent population to test the null hypothesis that population have the same median. Yeah. Okay, question number 10. Which one is not requirement from Kruskal? Okay. There are at least 3 independent samples. That is requirement. Each sample has at least 5 observations. It is requirement. The 2 populations have a normal distribution. It is not requirement. Fantastic. And the last question is, which of the following is not true? So the H test statistic, basically a measure of the mean of the rank sum. This is not true. The test statistics H has a distribution that can be approximated by chi-square distribution. That is true. An alternative hypothesis Kruskal test is that samples come from population with mean that medians that are not equal. Yes, Kruskal-Wallace is a right-tail test. That is also true, but this one is not true. It's a measure of the mean of the rank sum. No rank sum here. Rank sum is the Wilcoxon rank sum. Okay. Hallelujah. I am done.